Okay, this may be review for some of you, but today we're going to talk about vectors. Now, last year we did some vector addition with graphically, but we are going to stick with components this time because components are the most useful form. So just to review on components, let's say we had generic vector v. Looks like this. We can break that into its components. That is, its x and y components, where the x and y components are two vectors that I could add together to get the big vector, the total vector, if I wanted to. Now notice I've used dotted lines because technically v is the vector. These are just components. They're useful. We have to break things down into their components to use them for, say, a two-dimensional kinematics problem, but they're not vectors in and of themselves because they're just pieces of a whole. Now, what we have here is a right triangle. There's the thing. So if we call this angle theta, this generic angle, any kind of angle, then what I've got here is a right triangle, and I know that sine of an angle equals opposite divided by hypotenuse in a right triangle, and I know that cosine of an angle equals adjacent divided by hypotenuse in a right triangle. So if I apply that to this triangle specifically, what I get is that the cosine of this angle, well, adjacent is the x component divided by hypotenuse is the total vector. Notice that I'm now leaving the vector signs off. That is because these are magnitudes only right now. Now if I solve this for the x component, so multiply both sides by v, what I get is that the x component of a vector is equal to the magnitude of the vector times the cosine of the angle that the vector makes with the x-axis. And if I do that for sine and solve for the y component, I would get the y component of a vector is equal to the vector magnitude times the sine of the angle theta. Now this is very, 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 very important. Now notice this also means that the vector itself, if I had the components already, I have a right triangle and I can use the Pythagorean theorem to find the magnitude of the vector if I had its components. So I could also say that v equals the square root of, well, a squared would be like vx squared, and b squared would be like vy squared. So like that. And finally, if I wanted to know the angle, just the angle, let's see, let's use green for that because it's what I used in the diagram. Well, what I've got here is, I could use any of these if I already knew the hypotenuse, but what if I didn't? What if I just knew vx and vy, that's opposite and adjacent sides to this angle? Well, opposite over adjacent is a tangent. So the tangent of that angle equals opposite over adjacent. So if I wanted to know the angle, what I would do is I would take the inverse tangent of looks like that, of the y component divided by the x component, like that. So you're really gonna need these equations. These are important. Write them down. Okay. Now, the reason we care. Why do we care? In the past, we've basically just broken them down, and we will be doing that again. But something that we didn't really do last year, but we're going to do a lot in this class, is what you do if you have multiple vectors you want to add together. and you want to find what they are together. So I'm going to do some generic vectors here. Let's just do, oh goodness, okay, let's do, we'll call this, call it 5 meters, I suppose. I'm totally just making stuff up at this point. And it makes an angle of, 30 degrees. I know it doesn't look like 30 degrees, just pretend. 30 degrees is a nice number because it comes out well in sines and cosines and stuff. And then let's add to it, let's see here, how about, let's see, 4. How about 4 meters? And that makes an angle of 60 degrees to the horizontal. Should put a little dotted line in here too for you guys. Now let's say I wanted to add those together. So my resultant would look like this. I'm going to call that R for resultant. So it looks going to look like that. But how long is it? I can't do Pythagorean theorem. Well, I might be able to, but no, I don't know. I don't know that. I don't know for sure that that's a right angle. So I can't just use the Pythagorean theorem. So what can I do? Well, the trick is that I'm going to break this thing up into its x and y components. So, for instance, this has an x component that looks like this, goes to about here. And this has an x component that goes like this, goes to about here. If I add those two together, it will give me the x component of the resultant. I don't know if you can see that, but if I add this and this, I will get this. Okay? So the x component of my resultant is going to be my x component of my first vector plus the x component of my second vector, which the x component of my first vector from over here, x component of any vector, is the magnitude of the vector times the cosine of the angle it makes with the x-axis. So this has a magnitude of 5 meters times the cosine of 30 degrees, plus this has a magnitude of 4 meters times the cosine of 60 degrees. Okay? So, I plug this into my calculator, and I'm just going to go take a lookie over here. I got a calculator ready to go. So I've got 5 times the cosine of, oh, shoot. Sorry, this calculator does annoying things. This is why you need that TI. So this one makes me do like 30 and then cosine, and then that's the cosine of 30 times 5. Okay, so that'll be 4.33 meters plus, oh, hello. There it goes. Sorry, my computer got stuck. Well, the cosine of 60 is 1/2, so half of 4 is 2 meters. So I get 6.33 meters. Okay, back to full screen, I think. Alrighty then. The y component does the same thing. So what I use for this? I used orange before. Let's use this funny gray color. So this one, I've got a y component for the first vector that looks kind of like this. And this one looks kind of like this. Notice they're in opposite directions. That means one of them's got to be negative, and I'm just going to choose up to be positive, so down is negative. I have to remember that when I'm putting them together. And that means that my R, my resultant, will have a y component of about this. Now if you look, this minus this will in fact give me this. You can actually see them adding up. It's kind of nice. Anyway, so the y component of the resultant will be the first vector's y component plus the second vectors, y component. So this time, it's like exactly the same, but you change all the cosines to sines. Really. I'm going to leave the units out for a second because my hand is starting to cramp and I'm running out of room. Okay. Sine of 30 is 1/2. Yeah. So I'm going to get 2.5 plus, this time, sine of 60. 60 sine times 4, 3.46. So I get, I should have rolled that in my head well. 5.96 meters in the y direction. Okay. Oh, I'm going to have to turn the page. That kind of sucks. Okay. Now that I have the x and y component, to find how long r is, I go over here and use this black equation. So let's see if I can remember these. 6.33, 5.96. Okay, so that means that r total is the square root of, oh, I can't remember. It is too late in the day. 6.33, 5.96. 6.33 squared plus 5.96 squared. Calculator. Oh, this one's already up there. I'll just square it. Boom. Alrighty. Plus 6.33 squared equals square root of 75.6. So r is, oh, where's the square root? Oh, I took my contacts out and I'm looking in my glasses. It's not working very well. Okay, I think that's right. Let's hope. That looks right. I know it's got to be between 8 and 9, so 8.6. Oh, if I round properly, it'll be 8.7.0. Okay. And if I want to know the angle this thing makes, so this angle right here, I would use the tangent. Inverse tangent of 5.96 y over x. 6.33. Oh, let's see. Does this thing even have inverse tangent? I don't think it does. I do not see it. That is why you need a scientific calculator. I need one at home. Anyway, you'll have to do that one on your own and let me know what the answer was. I'm sorry. I could use Google, but that would involve opening another window and I'm just too lazy. Anyway, I'm going to throw some problems at you that's just doing this. This is all you're doing. There's not even any physics involved. This is just a math thing. So please come to school with some questions and we will do some practice problems together at school.